Cool. All right, everyone, welcome to the Brisbane Full Stack User Group. Tonight, I'm pretty excited to be talking about vertical slice architecture as well as clean architecture and diving in fairly deep into both, kind of showing the story of why you might choose one or the other, kind of, the benefits you can get, as well as how you can get up and running with either or. So without further ado, let's dive right in. So a little bit about me. I'm a SSW software engineer too here at SSW, like I said. I'm an open source developer, so I love to put projects I build just public there on GitHub so anyone can see it, steal the code, use it, whatever, all good with me. I love anything related to, software architecture. So, if it's a good idea, bad idea, something that's contentious or, widely accepted, I'll be keen to, stay up to date and have a think about it. I'm also just newly addicted to the gym, so that's fun. Always eating. And then you can find me on Twitter, GitHub, or my blogs down there. Guess it's called X now, right? Not Twitter, so maybe that logo needs changing. SSW has a little rewards app, so every event we run like this user group, you can download the app and scan a QR code at the end and get some points. So just for free, over time you can earn like a digital thermos or a smartwatch. So scan that if you're interested. So tonight, like I said, we're going to go through, what is clean architecture? So some of the basics. So not a super in-depth course, but enough to kind of go above just maybe the 4 layers if you know that much, a little bit deeper, and why we got there, as well as a demo. So just how you get up and running. Everyone's done the boilerplate for you, so I'll show you how you can get up and running really quickly. Following on from that, we'll do vertical slice architecture. So similar to the CA, we'll talk about, how did we get here? What are the benefits? Why might you pick it? And then a little demo, so how you can get up and running with vertical slice architecture really quickly. And then right at the end, a little hidden nugget I didn't advertise. So who's heard of a modular monolith before? Quick hands up. Yeah. Who's fairly confident with it, or they just know it exists? Hands up if you're confident you could, do it. Yeah. So right at the end, we'll kind of talk about the modular monolith a little bit, which is basically how you can gain the benefit of CA and VSA kind of together. So that'll be exciting to talk about. So let's jump into it. What is clean architecture and why? So right at the start of the story, right? What happens when you have no architecture? What might your software look like? Go on. We won't expose them, but yeah, so we had a chat before the session about some horror stories of what an architecture might look like. So, imagine, 4 figures of projects, circularly referencing each other, something like that, just as an example out of thin air. So let's assume maybe you've got a client making a request and maybe they're doing some, presentation logic, maybe some business logic, maybe some like system or data access. That seems pretty perfect world, and eventually it might hit the database. But that inner part is kind of a question mark, right? Maybe that happens, maybe that doesn't happen. It probably, over time, transforms into spaghetti where, you might start out with no architecture and have it somewhat clean, but you onboard developers and it lives for 20 years, and then everyone's got competing ideas. Some people do a hack here or there, don't document, why you may or may not do a thing, why you did a hack. Raise a backlog item of, fixing the hack you did. No architecture, no standards there. You're probably going to end up with a little bit of spaghetti architecture. In a project, this might just look like one project where you just got everything together. That's kind of a very simple example. Maybe you have thousands of randomly named things, maybe no conventions. People use dots of the company or the project, dots on it. Maybe you don't even have that. Maybe you have random names. Who knows? So it's a wild west out there with nothing. So that's the pain, right? With no architecture, who knows what you're going to do? It's going to be a big pain after a few months. Imagine, 20 years. So that's the monolith, basically. You're kind of just splatting stuff out. There's basically little to no abstraction. So you can think of that as a pro, right? It can reduce some friction. So that is an upside for a use case. It's quick to build early. You can go from nothing to deploying it, because you're not spending time on abstractions. So that is a benefit. It does have potential for performance. So I'm saying potential. I'm not saying your monolith is going to be super fast, But if you have less abstractions, there will be less CPU usage and stuff potentially. You'll probably write worse code because of the worse structure. But, if you're writing some embedded code that's ahead of time compiled on a, system where it's like that, maybe you're not going to write like all this abstraction, which is actual just, resources you can't afford. So that is a potential benefit. The downsides, well, the major one, right? You can probably just call it inertia. You start off really quick, you're writing code, you might just be, deploying it to a, server or in your network, or just deploying it to the cloud really quickly. But, that becomes a debt that increases, the amount of time to deliver. I think that's the major downside. If you don't have anything, quite difficult for multiple teams at once, right? Even one dev over 20 years probably will, result in a fairly spaghetti app. Imagine a whole team, imagine 5-10 teams. That's going to be pretty much a nightmare. A technology change. So thinking of a system that is trying to last a lifetime or a long time. If you're changing your technology or so a piece breaks, if you've got this architecture where anything can impact anything, a technology you're trying to change or something that breaks, you don't really know the wide impact of a bug, or the technology change probably will require, changes throughout your whole code base. And obviously that piece kind of makes it really hard to be tested. So, no architecture, no structure. It's very hard to keep stuff in a very testable way. So modularity and testability are quite hand in hand. Okay, so we've got this pane. Let's think of some ideas to keep it testable. Maybe we'll rip out some of the technical pieces. So let's picture basically the last graph we had, but actually, separate and make sure the structure separates those technical concerns. So a client might request into your API. So we're just going to assume, you're building an API. You can architect, software for any type of app, but, a lot of devs do enterprise stuff and it's going to be an API. So we'll just assume we're talking about APIs, but you can apply it anywhere, right? So ripping out some technical concerns, you might structure it with folders or projects or anything like that. We'll dive into how you might implement it later, but this is theoretical, right? So you might, at the top, you get a request in, you might do some presentation logic. So if you're on an API, you might do some HTTP stuff. You might have, JSON web API. You might be using another protocol like gRPC or, anything like that. Protobuf if you're doing game dev, maybe you're doing, really quick two-way message. Whatever's in there, right? You could do that alone, just how that interfaces. And then separate the piece where you're doing the logic. So once you're in the system, splat everything in there. And then below that is data access. So if you're doing your fancy logic of what should happen given data, use cases, things like that, and then talk to the database. So this would look like, maybe 3 projects in a, .NET app. Maybe you have your presentation layer, which is, ASP.NET Core, and that could reference the business logic piece where probably the most overused term in at least every project I see is services. Everyone's like, oh, this code does something. It's a service. Let's get away from services, guys. Think about it. So yeah, this is probably going to be the bulk of this code base, I think. And then the business logic references data access, which might be repositories. It might be something else. Maybe there's a third-party API or other systems, all the interfacing, or, ports and adapters. There's tons of different terms could be in there. So this one is called N tier, right? In this case, we had 3 tiers. We had, presentation, business logic, and data access. Those are our 3 tiers, and it's very kind of one-directional. So one kind of key thing to note is data access is at the bottom. So all paths kind of depend on the data access. So that's a interesting thing we'll look at in the pros and cons. So it is fairly intuitive. The abstraction's not painful, right? You don't have to build all these. We'll use Java as the example, right? Everyone knows the joke of like you'll have a factory manager, you'll have 20 different patterns to achieve a simple thing. Having NT, you've just kind of ripped out a few of the bits. You've kind of made it obvious where things in code should go to some degree. It is fairly quick to build as well, right? You could just write the projects and have controllers here, services in this project, and repository or EF core in the bottom. And that's, not really, intrusive to the dev experience. It has some improved testability, but we'll talk about it in the cons, why that structure doesn't work. Again, I think the inertia will increase, not as bad as the monolith, But I think as you scale, if it is going to be a large app or a long running app that's, undergoing dev time, I think the end tier, as you get complex features, as features kind of talk to each other and there's some intermingling, that inertia will kind of kick in a little bit. Again, it's difficult for multiple teams. So as, the intermingling might not be as chaotic as the no architecture. You still have the ability to, intertwine features and have side effects that aren't too documented. So because of that, multiple teams, you have like the IP knowledge of each team and their code base living with each team for the most part. And that gets fairly hard for each team to coordinate in one code base that's just basic end tier to kind of make sure there's no weird things going on. So you feel some pain there. And it's very similar. So the technology changes, like we talked about with the monolith, is going to impact the whole system. So let's try this one, zoom out. The data access layer is right at the bottom. So if you change this, every bit of code is going to change. Your service is probably hard coupled to EF core or a specific repository you've built or something like that. So that's definitely can be a downside. How about we get some clarity between kind of the business use, so logic and, kind of thinking in the DDD land of, what do we actually want to do? Let's think about our domain, and then separate the technical concerns. So, the important logic versus the, what we need to actually make it happen in code. What if we split those two up? Or we can kind of switch up this data access. So remember the end tier data access was at the bottom. If we pull it out from the bottom and put it on top, we get this structure where a domain and application. So for now, I'll dive into what those two are later, but think of this as your business logic. Together, these can make business logic. You now have no dependencies external in that business logic layer. So testability, you can mock out things really easily. You can change out what it actually does at the end of the day, whether it's a database or third-party service, and still kind of have your tests ring true. So this is pretty good, a good step. Anything that's a technical concern is kind of removed. And the happy path is, presentation and infrastructure are both kind of the peak, externals of your system. And then the, bulk logic is in that bottom layer. So what might this look like in a, project structure? Well, we bring out the Clean Architecture onion. So this is basically just another way to show the tree where we moved infrastructure out to the top. At the bottom, we've got the domain and application there. And they're both gray, kind of signaling that that's the core of the app. And then right on the outside, presentation and infrastructure are equally removed. And a key thing to note is that the arrows point inwards. So if you haven't really dove into clean architecture, the arrows are very, very explicit. And it is just showing hey, we are intentionally saying infrastructure is right outside and it depends on the system, not the system depending on things external. So that's very important. Now, who's seen this variant of the clean architecture onion versus, this one where it's got our 4 layers? Who's more familiar with this one? Hands up. Yeah. Who's more familiar with this one? Hands up. Yeah. About half and half. So this one is kind of more the original from Uncle Bob. And an interesting thing to know, if you haven't gone into the theory of clean architecture too much, the bottommost layer, you could call it domain or entities. A lot of people will make it really simple, and the term you'll hear online, if you know a bit more, they'll call it an anemic domain. And that basically means you'll just put your models, which are they're basically copying the table structure of your database and just putting that in the domain or the entities layer. But if you look over here, enterprise business rules, or business rules, that sounds like logic. So that's interesting. Use cases, the layer around it, so we can kind of think of that as the application from the other slide. That also says this one's application business rules. Okay, so our domain and application can have rules. What's the difference? Basically, the entities or the core layer is unaware of anything external. So in the graph back here, application has interfaces to know that there's something external. It doesn't implement it, but it knows that there's something external. Whereas the entities layer here just has little models. They're kind of pure functions. They act on the entities themselves. And then the use cases, you can think of that as like a aggregator or an orchestrator where it calls the entities or the enterprise business rules, and then, just calls a few things and chains with things external. Now, Uncle Bob's Clean Architecture, he's not saying that you have to do it in any specific way. Everyone kind of has their own interpretation. And this is, our own interpretation, my own interpretation. And everyone can kind of take this graph their own way. So the most common one is, you might have seen the popular Clean Architecture templates with those 4 layers in that way. And it's just one of the ways to do it. And then the outer rings, I won't go into that too much. But I thought that's interesting to kind of think about your domain layer and that it can be more than just entities. So yeah, that's kind of the two compared. So Clean Architecture, it's pretty good for those larger systems because it has the abstraction. It's resilient to the technology changes, right? The infrastructure, instead of it being right at the bottom, where everything depends on whether you're talking to SQL Server or whatever, it's kind of removed as its isolated piece. So that's pretty good, where if it lasts 20 years and you picked some really bleeding edge database or technology and it's been, huge security holes, or you want to move to something else, any big change is going to suck. We'll get that, out on the table, but at least you don't have to be, changing every bit of code. You don't know what's going on. It's kind of scoped. You know what you're getting into if you have a change like that. It's very testable from that structure. If you have a rich domain, which is kind of what you call the domain where you're putting logic in there, you can test with essentially no mocking, right? In unit tests, you might have mock. If you've seen MOQ or nsubstitute, you usually mock stuff. If you have a rich domain, you don't need any mocking. You're just kind of creating simple, classes, data, and then running methods from the domain and just asserting state. And that's very easy to do. So if you load a lot of logic into the domain, you can get some pretty cool tests. And then the application as well. If it's acting as an orchestrator, you mock a few things, you've already tested your domain logic, and you're just testing that kind of orchestration piece. So that's a pretty cool thing. If you don't do Clean Architecture well, you do lose out on some of these things. So there are trade-offs. There's a lot of abstraction to have that rich domain and just orchestration application piece. But if you want the testability, that's something to consider. It's not influenced by anything external. So the infrastructure or the data access is kind of a second thought. If you want to build your Clean Architecture app thinking of domain first or application, the inner layers first, the way you store your data or the way you send an event or hit a service bus or something, you don't care how it happens, you just care that it does. So it's pretty cool to think in a way of just writing plain C#, build some interfaces if you know it's not going to be within your system, and then write those interfaces later. Maybe you build out all your logic, just build a skeleton interface, and right at the end, you're like, okay, I need to write a row to 4 different tables from my one big domain model. How do we have, do this? And you just write that one method, and now it's wired up. So it is pretty cool to work in that way. Now, I think it's got consistent velocity, right? I think the inertia is a little bit less, where it's, instead of those exponential curves. To me, the projects I've worked on, you have a pretty high cost right at the beginning, where it's just like you're setting up all these things. It's, not as quick if you've built your own personal projects with, again, no architecture, but it is consistent. So, again, if you're working on this all day with lots of people over a long time, you can kind of have the same expectation within a few years of like, these features aren't going to be scaling up crazy amounts. But it's definitely going to be increasing slowly. Any code base that gets larger has, a cost associated to it. Because of the separation and kind of abstractions and the testability, it's easy to work on by, a few teams at once. So, if you've got that good test coverage, really utilizing the modularity of the inner layers, you can have more confidence as, maybe you're another team, maybe you had to touch the other team's areas a little bit. If they've got that test coverage and the test is still passing, you can kind of sleep easy at night, not worrying like, oh, we're going to have a big production bug in the morning and I'll have no idea what they're doing. The whole team's on holidays, on a cruise. We're not going to be having a good time if something goes wrong. Like you got a little bit more peace of mind, and that's kind of important for sanity, right? So it does have the higher barrier to entry. I think the major problem I see on the clean architecture projects is, a failure to train or, understand the theory behind it. So you might go on a project and kind of understand the layers and what you put in there. But every project has different pros and cons, hacks, trade-offs, whatever. So without kind of understanding the theory, you might not understand why people made a certain trade-off, what costs are they, saving or, paying down for what benefit, what are they losing out on? And that can cause a lot of pain where people are butting heads. You might have a purist that they want this perfect clean architecture, and then you might have some people with trade-offs, and then, they're butting heads because competing concerns, and then you're basically on the do anything architecture, right? If it's slightly different opinions over time, that'll add up. So, if people don't have their perfect architecture, it's still better to be consistent, I think, in the long run, where people are fairly close, but consistent. So yeah, that's definitely a barrier to entry, but it does depend on the training. And definitely discipline. That's a big important keyword. If you're not disciplined with it, you're going to slowly introduce these problems where maybe you're going to skip a few layers, maybe you'll muddy some logic together with the external systems. I think the major problem is in N tier, right? We had everything leading down to data access. You can get lazy with clean architecture and splat all this logic in your infrastructure layer. So, I've got to talk to the database. So, okay, I'm talking to the database. But I need to do some logic. So, I'm already in the database layer. So I'll just do a little bit of logic. Or you need some discipline to go, hold on. All I'm doing in the infrastructure layer is I've got this thing and I'm doing it external or the other way around. And then I'll bring it back into the inner layers of my system. Looking at the onion, you should basically be scared of these red layers. You want to, if you're in the red layer, you go like, hell no, this is scary. You want to get out and get right back into the application and domain as quickly as possible. And that's kind of where the discipline lies, where it's like, hold on, I'm spending way too long in infrastructure. Am I doing something here that, could be in the core layers? There's lots of other examples, but I think that's the major one that you see in most code bases. Let's jump back. So yeah, obviously slower development time overall. So because it does have the consistent velocity, you've kind of got just that slower thing of building these in the right ways, thinking about the layers. There's just a little bit more involved. Lots of code to write a simple feature. I think, without having done lots of time on clean architecture, that's probably the common complaint. It's like, I have to write all this code in all these different places just to do a simple CRUD API. Like, why do I have to do this? If you are just building simple CRUD APIs, do you need clean architecture? Like, maybe it's a wrong choice. Maybe you just need N tier if it is really going to be CRUD. Maybe you use one of those, generator things or GraphQL or something like that. If you're not really doing much logic, if you don't need the benefits of clean architecture, the cost, is it worth it? All right, let's jump into a demo. So I'm going to show you how you can get up and running with ASP.NET Core and clean architecture. So let's see. Let's zoom in. So what we have at SSW is a clean architecture template we've developed. So it's very similar to the ones out there, just with a few changes and random quality of life things. So it'll be familiar if you've seen either Ardalis's template or Jason's template on GitHub. So let's create a new directory here. So I'll just call it, CA demo, and then CD into it. Now we have a .NET new template. Who's seen the .NET new template engine? Quick poll. Right. So if you haven't seen it before, basically, instead of copying like a code template or downloading a zip or anything like that, it's kind of just a little, search, find and replace template that'll bring that code in from a NuGet package or something like that and apply it to your project. So let's say I'm calling this project ca.demo. If I use the .NET new template of the SSW CA project, it'll bring in this up. And if I list what's here, okay, maybe it's a bit big, let's run it again. We've got a solution file here. If I open it up in Rider, we can take a look at what we've got. See if it opens. There you go. Let me just zoom in. Cool. So within the template, you've got a bunch of things, but I'll kind of keep to just the architecture and the structure to keep it simple. So we've got those 4 layers from the onion before. Web API here is the presentation. So all it's got is features, and within those features is just the endpoint logic. So in a web API that's HTTP, all it's going to do is the HTTP logic. So in this case, it's, saying on this route, I'll send a request inwards, and maybe some Swagger documentation. So the Swagger docs, that's coming out of the box, and just saying, hey, when you send this request, it'll respond with this data type with a nice name. Now, who's used Mediator as well? Quick poll. Yep. So it uses Mediator, just kind of like most projects. So it just sends that request inwards. Mediator is just a nice way to kind of work with clean architecture. It's got tons of benefits, right? But as a way to enforce clean architecture, it's nice to separate your, presentation logic to get into your application layer, where the Mediator commands and queries kind of stay within the application. So there's other things in there, right? Health checks, exception filters, but that's not too important for the architecture. Jumping on into the application, like I said, it's got those CQRS objects using Mediator. So commands and queries based on features. Within the feature, you've got the command, and like I said, there's trade-offs. So our template, we decided to use EF core essentially within the application. Now that's infrastructure, right? Well, it's really painful to rip out your complex query logic and things like that. So most projects using CA will kind of use the DB context within the application layout. So this isn't purist CA, but there's a few kind of trade-offs we've done to nicen it up a little bit. So the first thing you'll see is we've got this with specification thing. So this is a package by Ardalis, so another big CA guy. And essentially what it means is within your domain, you can have query logic. So in the template, it's very simple. Imagine you're spinning up a new web API project. Microsoft has like the weather forecasting, right? So it's got a simple to-do item in here. But you can chain basically all your link queries in here. You can do anything, crazy that you want to do with your normal EF queries. But this is in the domain. So you're doing data access, but abstracted away from the actual provider in your domain. So it's a rich domain. Now, we wanted a rich domain so we can test it. Well, let's look at the domain unit tests here. You can test specifications as well. I'm not certain if it's in this. It might not be in the template, but because it doesn't rely on anything, you can test this very easily and just execute it on a raw list and run the specification and get an output. So that's pretty cool. Now there's the normal commands, queries, fluent validations, things like that to get up and running. Now in the domain, it's got slightly smarter entities. So it's not full DDD, but it's got starting to get some logic. So object creation, maybe some default state, maybe a bit more focus on a value object theory where you're like, hey, I want my entities to always be valid. It's not applying all these rules, but it's kind of hinting it there. We're not, enforcing all these, really hardcore concepts. It's just kind of lightly pushing you in the pit of success where it's like, have a think about this, give it a go. So yeah, I won't bat onto that too much. In the infrastructure, it does all the EF core stuff. So it, throws all that scary, column mapping and constraints in the infrastructure. I won't dive into the domain events. That's a topic for a whole other talk. And whatever else you need there with seed data or migrations. So that's kind of a basics intro to the template there. One cool thing is you can spin up a whole query using the templating engine. So you don't actually need to create files and stuff for a feature. You can kind of just run a command and say, hey, I want to be able to create a user. I'll call it that based on an entity called maybe users, and then maybe the namespace We'll allow writer. Hopefully that doesn't brick anything. Based on what do we call it? CA demo or something. Now I think you have to run it in the right folder. So this might create them in a Wild West structure, but I'm doing a live demo, so who knows? Created successfully. Oh yeah, I didn't scroll down. There we go. So yeah, you're meant to run it in the actual application layer, but you can kind of see the structure. If I cd into commands here, it's created a whole create user within that feature, and then within create user, it's got the command and a validator and linked up to an entity. So a bunch of the boilerplate is used with that templating engine. And even if you don't get anything away from this talk, if you've got a big app where you've got similar structure within your app that's somewhat consistent, it's very quick to get this .NET New templating built and running yourself. So if you find yourself writing very similar code, you can create one of these templates yourself and just deploy it across your whole team, and they can just kind of get sped up, which is pretty cool. All right, so that's kind of the basics of the Clean Architecture template. Moving on to vertical slice architecture. So, Clean Architecture, what really happens when we do a request or a use case? So a use case is kind of just like that business enabler, like you're enabling something to happen, thinking less of, the code of just like, hey, I want to be able to achieve something. So what happens when you do that? You might have some UI, whether it's, physical, WinForms or something, or a web API, some way to, talk to the system. You might then go to a service or a, command handler or something like that. We'll overuse service again because, everyone loves to use service. Maybe you talk to an entity and then maybe you talk to a database. This is fairly similar for most CRUD operations, right? So there's some similar themes there. We've got presentation at the top, right? If we're thinking of the template or the project structure, that would be a web API project, application for those services or command handlers, query handlers, things like that. Your domain might be these entities. So these all might be the same entity. You might have a different entity. Who knows? And then in the infrastructure, you'll figure out how to actually save it to the database or query the database. So yeah, kind of everything talks those same layers in somewhat of the same structure. Now, it doesn't have to be this way. This is obviously just CRUD. So in a larger app, things could be, doing lots of application, jumping back and forth a few times. Who knows? But for the, sake of demonstration, this is just a CRUD operation. I want to introduce the proximity principle. What is it? It's basically just saying, hey, code that changes together should live together. Now, what does that mean? Well, if I jump back to Clean Architecture, the template, let's say we have the to-do feature. So imagine I have 100 features within this code base and I need to, add a new field to the to-do, section of the app. I have to jump into this web API project, hunt down, where is the to-do endpoint? Okay, it's here. Okay, it goes to a query. Where's that query? Somewhere over here, dive in. Oh, is it command or a query? I don't remember, jump in. Maybe it's create. Okay, this talks down here. Okay, what does this create thing do in the domain layer here? Okay, it does something. It raises this event. What does this event do? You dive into this rabbit hole where you're touching every single layer, you're bouncing, quite often. And that's pretty scary for a new developer as well. Like imagine you onboard someone, you tell them a fairly simple feature, but now they have to be touching kind of all across your code base. Now, this principle isn't a hard and fast rule you should apply everywhere. It's just another tool in the toolbox, right? Maybe you want to have it live together. Maybe you want the technical concerns abstracted. So what if we apply this principle to, a code base? So instead of having code separated by technical concern, so whether it's the presentation bit or the infrastructure or logic, let's kind of group it by what happens when I want to achieve something. So I want to achieve creating an item in the system. I want to read an item, delete an item, right? Now we can rip away Clean Architecture. And what if we just put everything we need to create a to-do item within one folder? What if I put everything to do get in one folder, and so on? And this is kind of the basic premise of the vertical slice architecture, where instead of separating your concerns of the code by technical concern, it's separated, kind of thinking of flipping it 90 degrees like the graph, right? Instead of horizontal, you're separating the concerns by feature or use case. So what does that look like? You might have the common web API, right? One point in. You might have a feature to create a to-do item. You might have some presentation logic and then business logic and data access within all these features, and they might all talk to the same database. Now, they also might not. You might have microservices, so they could be a form of vertical slices where each piece of functionality is its own individually hosted piece. Now, is that a good idea? Maybe not. It could be. You could go super purist, but we'll talk about that a bit later. But you might just have the one API, a bunch of folders, and a bunch of files within that. So you might have a file for your endpoint, and then next to that, you'll have a file for your business logic, and next to that, file for data access. And again, we'll look at that later. So, vertical slice architecture. I'll do a demo later, but basically it's good. It's got little to no abstraction, which is pretty cool. Low barrier to entry. So again, imagine that, use case where you hired some new dev, maybe they're fresh, they don't know too much about dev work. You can put them in the one folder and they can go wild, and they're not having to jump through this big structure they don't really understand. Now, any onboarding process isn't going to be just hit the ground running. It's still going to be a process to get up to speed. But that's pretty cool to have everything within the same folder or area or some sort of grouping. It's somewhat resilient to technology changes. Now, there's nuance to this, right? Within a vertical slice, you have complete control. So if you're very purist, well, you can do absolutely anything within the vertical slice. So if you imagine right back to the start of the talk with a monolith, where anyone's doing whatever they want, they're doing what they think is best. Now, what if we apply that same thinking within each vertical slice? You could have people basically creating a spaghetti architecture, just calling it vertical slices, because they're like, well, I can do anything in the slice, so I'll create my spaghetti mess. And therefore, maybe it's not resilient because you have to change 400 different technologies if you want to make a change. So there is nuance to that. Now, if you architect it in the right way, it's resilient. Level of testability, like I said, it depends how you do it, but it can be per feature. So maybe you've got tight deadlines for a few things. Maybe they're not hot pass. Maybe they're not mission critical. You got budget concerns. Maybe you write your few features that you care about to be really testable. Maybe you write other features to be pumped out really quick. It's kind of up to you. Because of that grouping of IP and kind of the business feature use case being grouped within the folder, it is easy to work with on multiple teams. Because again, if the team is working within folders, they don't have to be worried that their folder somehow other people depend on their folder. It's very kind of distinct in that you shouldn't just be working within that little slice and not going sideways. Feature changes have no impact on other features if you're architecting in the right way, of course. So you can sleep well at night. I love to sleep, right? So this keeps me very happy. I can deploy a change and not be just up stressing, having a nightmare that, again, I'm going to get a call at 2 a.m. that something really bad happened. So we didn't really talk about it, but we looked at the simple CRUD examples. In a real app, you're going to have features that impact other features. Now, how do you do that in vertical slices? Well, if you have that kind of bigger system that's more real world, you do require that code where you're making it distinct that basically you're doing what microservices does on an infrastructure level, where they're doing messaging over the network, but you're doing messaging within the same app, where it's like, here's a contract, I want this to happen, you handle it. So you have the boundary of saying, please make this happen, and then another slice can make it happen. But that is overhead. So that can get complex, that can be done poorly. You do need to put a little bit of effort into thinking of what those contracts are, how those messages work, but it can work pretty well. And like I said, if you write your feature in a different way every way, you're going to have pretty bad cognitive load switching between features, because it's going to be like you're onboarding, offboarding from projects, however often you switch between features. All right, so we talked about, a little bit of theory, but how do I get up and running? So let's say I've never seen it before, but I want to try it out. So let me jump back to the demos folder. Again, a .NET template, so I've got one that I've made. So you can start a new vertical slice architecture solution. And then if I open Rider for the, I should make a folder for it first. Let's call it North Wind. and then cd into that, and then create the new template. The template, automatically detects that folder, so it's pretty cool to just call the solution the right file. And then we can open that in Rider. I should give it the solution extension though. Open it up. And what have we got in here? Well, we've got one project, which is our app. And within that project, we've got a bunch of features. And within the features, kind of feature grouping, you have your real features. So bringing it back to simple CRUD, I've made some trade-offs. So some of the things to speed it up a bit, some of the things slow it down a bit. The things that speed it up is within the feature grouping, we've kind of got a consistent repository. So if you're going really super purist in vertical slices, let's take the create to-do as an example. So ignore everything in the structure for now. If I'm going really purist, inside create to-do, I need to do data access. So maybe I need create to-do repo to do data access somehow. Maybe I need a README. Why is there a create to-do, some business context on it? Maybe I'll actually create the UI. So let's say I have a Blazor front end. Maybe you'll create the create to-do form as a component within this folder. Maybe you'll do something else. Maybe you have an entity for create to-do. So not just one shared to-do, maybe you have an entity. Maybe within this entity you need migrations. So if you change that entity and you're deploying it, maybe you need migrations. Maybe you're doing the migrations really poorly. So I'm doing my bad SQL script. Maybe you're doing that in there. We talked about making trade-offs and not documenting it. So maybe you've heard of ADRs, which is a way to record those decisions and where they came about. So maybe you're deciding per feature, I want an entire ADR there where I've got every record of why I made a change, and so on and so forth. So this is kind of really showing the extreme of, you can go really purist, everything you need completely isolated for this. But, that's, like I said, extreme. So I'm just going to delete that folder. That's not going to be saved. All those files, painful. So the trade-off is, you've got a repository shared within that grouping. Let's kill the second one. And it's got, an interface. So like I said, we want it to be somewhat resilient to those external systems changing. So we'll use an interface. I can switch this out later, but we'll use EF Core for now. Shared within the feature is the entity. So to-do entity is used among all these 4 bits. Dependency injection, so you can just add what you need within those features once. Now I'll talk about this at the end of the talk, why this can be useful instead of just splatting all your dependency injection at once, but it will come in handy later on. Now, has anyone heard of fast endpoints before? Quick poll. Yeah. So this template just uses fast endpoints. It's a pretty cool library with some benefits, but it's pretty new as well. So later on, we might just go minimal endpoints, but it's pretty cool for a vertical slice application. Within an endpoint, so this is using fast endpoints, it takes in a request and an output. So to update the entity, I take in the entity itself. Now the vertical slice, this method here says, hey, put on /to-do with an ID, and it's unauthenticated. Well, this is one bit. You could think of it as a technical concern being split out a little bit. It's not really enforced, but because we're using the library, we have that method forcing us there. So it's kind of pushing you to keep some separation, but you've got your HTTP logic and some logic right below. So it's pretty cool to just jump in. I can change the route. I can have a repository and then do some logic. So in this case, it's just, doing update logic. We won't dive into that. And that's kind of the basics of a vertical slice app, right? You have a folder. You can pick how hardcore, what trade-offs you want to make. Same with Clean Architecture, and go from there. So the template, I can just demo it working. We'll run it up. So fast endpoints has Swagger as well, so you just run it. It'll all work magically with those endpoints. Within to-do, you can get all of them right. There's none there. We can maybe post one and just create one. Oh, I deleted it, yeah, because never mind. I deleted the entire post thing because it was too far gone. So We can't create any entities, but I promise it will work. Next time I won't delete the folder. But it was good for effect, so I'll live with my decision. All right. So that's the vertical slice template. We'll jump back. So that's kind of how you can get set up quickly, up and running, right? If you use the thing, you can hit F5 right away without diving into the code and have endpoints working. You can create a model and maybe with those item templates. So I showed it in the Clean Architecture thing. We can create a command or query. This template will get those item templates soon, where you just can create a feature and it'll do that shared repository, shared entity, and get you up and ready to go. So yeah, that's vertical slice architecture. Now, the little golden nugget at the end. How do I get the benefits, at least some of them, of vertical slices? But hey, I've already got this big code base with Clean Architecture already. So what's the problem with Clean Architecture? Let's say you've got a little e-commerce app. It's got a bunch of features. Maybe you have authentication and a bunch of features within that. Maybe you've got a cart and a bunch of things within that, and so on and so forth. This is a small example, right? Maybe there's only 20 groupings of features and a few things within those features as use cases. Now, authentication is somewhat removed, but what are some things that should be together? Like maybe products and cart is grouped, but it is just alphabetically ordered. So things that maybe are somewhat together get really sparse. And then when you have that same feature format among the 4 layers in Clean Architecture, you start scrolling quite a bit or relying on, hotkeys to navigate and things like that. So that can be a bit of a pain. One step in the right direction, maybe you'll just add another level of grouping among features. So one thing you can use is area folders. So it's just think of features with their use cases. Areas have features. You can have many areas. So maybe I have user experience as an area where the user is able to log in and reset their password, but also view their profile and edit their things. Maybe there's a marketing team where to enable them, they need to be able to get reviews, look at them, send out emails, things like that, or some sort of analytics and recommendations. So this is pretty cool. Let's say maybe we have 5 teams. Maybe there's one team working on user experience, maybe one team working on the shopping experience, things like that. A benefit you can have with the areas is if you use GitHub or any other kind of tool has this as well, you can put code owners on the areas. So jumping back on the features, it's very hard to lock down kind of code review, forcing someone to have, the right person to have the eyes over the amount of features. Code owners on GitHub has a fairly small size limit. So, in theory, yes, you could fill it all out, but you'll hit the size limit and then you're done for. If you put everything within an area folder, you at least just link it up to the area and then put things within the area, and it can scale a little bit better. As well as helping teams just stay within their area folder, for the most part. Obviously, you're not forcing them within that, but it just helps them have peace of mind that they're working within this feature. So that's one step. But modular monolith, we hinted at it right at the beginning. It's pretty cool. It's very involved. So, maybe it's not the right choice for a lot of apps, but if you're really big, maybe you have, 100 teams, lots of features, thousands of endpoints, whatever. Maybe it's something to consider for the pros and cons. Clean Architecture, let's take one onion. Let's say our app has one little onion. What if we throw another onion? So maybe this is like vertical slices, but of a whole app. So maybe we've got like an onion, another onion, another onion. Maybe even like a little vertical slice piece. Maybe. Now, what if we have like a gateway? So think of like a reverse proxy or whatever you might want to call it. So in the old days, it might be Nginx or something like that. What if we have a gateway and then these modules, the gateway just points to these modules. Okay, and then what if we call these modules something? And then have a little piece to the side that's kind of cross-cutting that each module can touch. Now this is kind of like the 10 seconds of modular monolith. Now what does it actually mean? It basically means each module here is completely isolated from the other modules, except for the messaging piece. So we talked about with vertical slices that, in a real thing, the marketing might need to fetch a user or fetch something about them or, update something about them. These modules will have to talk to each other. So, they're isolated, but because usually you'll build it in a project structure, you do enforce that boundary a lot easier, and you have to use the messaging. But because it's isolated, that the changes you're making are bounded within that module. And because you have the messaging to do module to module communication, it's very distinct that, hey, I need to talk to this module. I'm going to do this change, whether it's updating state or dispatching something. So maybe similar to Mediator, you're doing CQRS, where it's very obvious whether I'm updating or fetching. Now, the piece where it's kind of that middle ground between vertical slices and clean architecture is the modules of the vertical slice, right? Instead of a Wild West in the vertical slices here where you can do anything within a feature folder, you have an entire clean architecture piece in the module. Now, I'll show you a little bit more about that in a second, but the shared kernel, I haven't touched on that. Think of any shared bit of code that you need within the modules. So maybe you're doing DDD and you have the idea of an aggregate root or event sourcing or things like that that are going to be used among every module. You put that in the shared kernel and each module can just look at that shared kernel. Maybe you also have kind of common infrastructure. So if you're using EF Core across everything, you can put that in a shared kernel as an infrastructure project within that. But again, you should try and think of putting as much within a module as possible. And you can also, again, go as wild or as tame as you like. It's a trade-off. You could not share any infrastructure code. You could have a database per module. You could share a database. You could have an DB context per code base, one database, but a DB context per code base. You could have a shared DB context. It's kind of up to you to decide how much abstraction do I need? How much isolation do I need? What are the pros and cons that I can get from this? So let's jump into a real example. Now, I didn't build this one, but it's open source. So let's kind of take a look at how it works. Now let me pull it up. So this is a little e-commerce app. So similar to the example we've been looking at tonight, built by a guy open source here. I won't even attempt to pronounce his name, but it's all on GitHub and at the end there. So definitely check it out later. We're not going to dive into the specifics of how modular monolith works or anything like that, but we're just kind of hint you at it so you can look at it later on. Within the source here, we have the API. Now, software is famous for many times for the same thing, right? So in this case, the API is that gateway or reverse proxy or whatever you want to call it, but it's the entry point where it actually doesn't do anything, but it is the running ASD.NET 4 instance. We have building blocks over here, and this is the shared kernel. You see it called building blocks, shared, whatever. Once you kind of get the theory, you can identify what it is, right? So shared, you might have some idea of caching. Maybe each system needs access to MongoDB. Maybe each module needs access to EF Core using Postgres. Maybe you need some logging, maybe auditing, things like that, right? So these are the building blocks this guy's built, and definitely look at them later. Now within the modules, this is where you put your actual logic. Now, a module, you can write anything. So I looked at the template here, and we have clean architecture in here. So let's say you have a big clean architecture code base. You can first move to the area folders here as step one and organize it that way. And then maybe you might choose, okay, that's not good enough for us. And then you might say, okay, let's move these area folders into modules and just drag and drop them, right? Now, you will need to rip out that shared kernel piece. So obviously talking about it's easier said than done, but the idea is there. So within the module here, this guy's chosen to go for more of a just straight up monolith approach, kind of hence the name. Each module you're fine to write as a monolith because it is smaller and isolated, but you can write it as clean architecture. You can write it as vertical slice architecture. It's up to you. So yeah, we can look at what he's done here. There's features, maybe some data access specific to that module, maybe some entities, strongly typed IDs based on that aggregate ID, maybe exceptions, and based on that, you might have application and domain within it, services, things like that, just all splattered into a module there. Now, I won't really go deep into it, so that's just kind of the basics of what he's done here. And the testing there, you can test your shared projects, you can test your modules, nothing too unique in the testing there. So jumping back, what should we use? So we've got the idea of a monolith, N tier, clean architecture, vertical slices. You can use a modular monolith with just a monolith in each module. You can use a modular monolith with clean architecture in each module. You can use it with vertical slices in each module. You can mix it up. You can do anything in each module. That's a lot of options. Like, what should I pick? Well, I think you need to look at the pros and cons, right, of each one. Do I want that really quick speed? How long will it last? How many people work on this? Is it just going to be built for a few months and then maintenance, small touches, but lasts a long time? Like, take some planning. Like, you don't need to solve every problem that doesn't exist. Engineers obviously like to solve a problem that's imaginary or doesn't exist yet. So there's obviously, like, a trade-off again. There's no exact answer in anything, right? But, you can have knowledge and think about things. To me, have a play with vertical slices. Have a play with clean architecture. See which one works within your team, which one works for you. Then maybe if your project scales, you can move to a modular monolith. And the training within the team stays consistent if you pick the modules to be architected in that way that kind of fits your system. So maybe the clean architecture or vertical slices were right for your system at the time, and then maybe it's scaled, and maybe you're worried, so maybe you do just move that same architecture but replicate it within the modules, and then you're not going through crazy infrastructure where you're doing microservices. But the option is there, right? If you have a gateway, maybe the gateway points to one module, and then you deploy another instance where the gateway has one module. So that is another cool piece of modular monolith, where it can eventually become microservices with not too much code to be changed. But again, that's a whole nother talk, so I'll just leave that as a hint to look at later. Now, some resources here, so I'll just show a few things to pique your interest for later. If you're interested in clean architecture, SSW has a rules site, which is a collection of the best practices among a whole bunch of different things. So we have a bunch on clean architecture, so some that are an intro to the principles of clean architecture, various things to apply it within a code base, and random tips. We sort of strongly typed IDs as an example. They're pretty cool, right? Small code change to just protect against simple things. So, a rule here on how to get it up and running within a code base. Random tips like that. Cool stuff. So yeah, that's the rules. The template that I used for clean architecture is up on GitHub here. So, check it out if you want. Make a change, make a feature request, whatever. That's the SSW template. It has a big list of all the features it's got. I didn't dive into it, nearly as deep as you could in this talk. Here's the vertical slice architecture repo. It's on my personal account here. How you get set up, and just simple feature list. Give it a star if you think it's cool. And then this guy's modular monolith that we explored a little bit. Give it a star. It's definitely not easy to work in open source land, and it keeps the guys motivated. So I'd jump on and give him a star. It's pretty cool. All right, so yeah, if you've got feedback, scan this thing. It'll take you to a Microsoft form. I appreciate any feedback, good or bad. Definitely bad, because then I can learn from it, right, and never make the same mistake twice. So if you've got any feedback, please fill it out. I will read it and make sure it gets actioned for whatever next talk. Cool. So yeah, in summary, we just had a chat through the pain and logical flow of these architectures over time, of how we might have moved from a monolith to clean architecture or things beyond that. Same with vertical slices, how we got there, and what it does, and then obviously how to get up and running really quickly with both CA or VSA, which is pretty cool. And I really hope the modular monolith is something that piqued your interest, and you'll go and explore that later on, because I think it's pretty cool, and something to apply in larger code bases for sure. So that's my talk. Thanks guys for listening along. I really appreciate it. Cool. So I've got Nick up here. He's going to ask the questions we've got from the chats or the other offices. So fire away, Nick, if there's any.
Well, yep, there's definitely been a few. So
right.
Thank you so much. That has been a fantastic talk. Like Adam said, it's a very important topic. Before we go to the online and the international questions, are there any in the local audience?
So The microservice is like a way to host it. It's the infrastructure piece where, like I talked about with the messaging thing, where if it's hosted within the same app, you might have a vertical slice that's communicating using Mediator, something like that, where it is within the same instance. Whereas if it's a microservice, that communication between slices or modules or pieces is done over the network with like a service bus or a sidecar. So it's the same concept, but microservices is really painful to build in terms of the infrastructure, like Kubernetes and setting up, Docker containers and scaling, all of that stuff is really complex. If you don't need that scaling and infrastructure bit, the vertical slices gives you the benefit of kind of isolating the logical piece, but saves you the pain of the infrastructure of microservices. So that's kind of the difference. Yeah.
Of course. So that question there was just with regards to difference between microservices and VSA. All right. Any other questions? Right, yeah. Good. So from the online, we've had a statement made that VSA is just clean architecture sliced the other way. What is your response?
Yeah, it can be that way. I think in a real app, you'll probably see it that way. I kind of looked at it on this slide. It's really easier without the animations, where it is just kind of rotated 90 degrees. So you could build it flipped on its head, where it's just, instead of clean architecture as projects, you have it within that slice, but you have the freedom to build it anyway. So, it could be, you could think of each feature folder as a clean architecture little module. You could, it's a bit of a reach, but you could think of a vertical slice app, if you're building it that way, as a module or monolith. Now we're reaching here, so don't quote me on this. But you could think of each little slice as a module where you could be building that in a clean architecture way. It's a reach, but yes, it's definitely possible in a way you could do it. So it's something to think about.
Another question that we received was, what can we do to prevent code from one slice directly calling code another slice? Or maybe to rephrase it slightly, how do we dissuade programmers from that sort of cross-calling?
Yeah, I think the major thing is automating things away, and I think you're a big fan of that as well. We don't want to be having to check it at code review time or way too late. So a really cool thing that I didn't touch on is architecture tests. And that's a way to test kind of meta about what the code is. So you can test that maybe folders aren't referencing other folders, or even easier is projects or assemblies aren't referencing other assemblies. So without architecture tests, if you're building project-based modules or slices, you get some protection against circular dependencies, which you'd run into pretty quick if you're not doing anything with messaging. But it does not stop, one-way referencing. So the step above that is an architecture test, where it's just another unit test someone will run, or it'll run in the pipeline, whether it's like a pull request check or check on main, and say, hey, don't reference anything other than the contract or the messaging, assembly where we've got, just think of a protobuf file where you've just got all the contracts, and it's like, okay, here's what I can send and here's what I can receive. If you have a test like that, you automate it away, and then you can, again, like I said, I want to be able to sleep peacefully at night. If I've got the test, I'm more inclined to sleep peacefully, not worried that someone might butcher things up. So that's the major way to do it.
Another question we've got is, does a VSA application require a shared kernel, or is that just recommended?
The VSA app didn't have a shared kernel. The modular monolith did, but there was some common code in the VSA application which you could think of as the shared kernel. Now I kind of touched on it with that, painful example of putting every single thing you could possibly have related to one piece in the folder. So if you didn't want to share any code within a VSA app, you could follow, something like that, where you're putting everything, whether it's data access scripts, within each slice, and then you'd have no shared code. That the only exception being the infrastructure. If you want it to be incredibly purist, you would be even on the infrastructure piece, we have a microservice per folder. But I mean, the expense of, first of all, developing that and running it, the trade-off to me is way, way out of whack. But, the option's there. Yeah.
All right. So just one thing that I wanted to check, considering that we have the SSW Clean Architecture Workshop.
Yep.
Does that mean in future we can look forward to the SSW VSA workshop?
You might stay tuned for it. We might be building one. The option's definitely there, but there's nothing locked in yet. But if there's interest there, we might build one. Yeah.
All right. Well, those are the main questions that we've received, unless there's anything more from the audience.
Check. Cool. No, I think that's it. That's a wrap. Thank you, everyone.
Thank you. Have a good night.